Hey guys, today's lesson is going to use all the SOH CAH TOA stuff that we've been using the past couple days. However, in these word problems, you're going to need to create the diagram. So in chapter 5, we've been dealing with right-angled triangles. So in most of these diagrams, if not all, you should have a right triangle. Before we get into it, there is one new term, or a couple new terms, I guess, that are important for you to know. When we get into the problem, first thing that you need to do is to draw a diagram. Okay, there are marks given for that. That's how you show your thinking and how you're reading that problem and converting it into a mathematical form. Okay, so always draw your diagram. Then once you have your diagram, you're going to label the pieces. Just like when we were doing stuff last week, you labeled the opposite side, the adjacent side, the hypotenuse. You labeled the measurements you're given. And then also, maybe, is there anything that you're not given but you could find? So angle theorems, Pythagorean theorem, similar triangles, etc. The new terms for today, though, and you're going to see these in the problems, are angle of elevation and angle of depression. The angle of elevation, we do well with that one. Students intuitively know where to put that angle. Angle of depression is the tougher one. Both of these things, so if you read a question it says angle of elevation or angle of depression, both are measured from a horizontal line. The problem with depression, angle of depression, is we don't often see a horizontal line. What does that mean when I say they're both measured from a horizontal line? Just this. So you might want to pause the video and kind of just draw this diagram in. Here is a horizontal line. If your diagram already has it in, awesome. If it doesn't, then I add one in, and you'll see that happen in a few of our examples today. The angle of elevation is the angle made when you look from the horizontal up. Okay, so as you elevate, the angle of depression is from the horizontal going down. Right? And if you look, like using a person is a good representation because assuming they're not texting on their cell phone, they're walking and you look straight ahead when you walk, right? You're looking on a horizontal line. So if when you're walking, all of a sudden you look down a bit, that angle that you're measuring is from the horizontal going downwards. So, first problem. A monument casts a shadow 13 meters long. The sun's rays form an angle of depression of 63 degrees. Calculate the height of the monument to 1 decimal place. I would pause the video here, and can you draw the diagram? Once you have the diagram, it's the same math as before. So take a minute, pause the video, draw the diagram. Okay, hopefully your diagram looked something like this. You can see that we have a monument, right? The monument is going straight up and down. We will assume that buildings, trees, poles are always built perpendicular to the ground. So they're always built at a 90-degree angle. And so down here is the ground. Common mistake is to put that shadow on the hypotenuse. A shadow only appears on the ground. Okay, so now that you've seen it once, you'll get it right the next time. Okay, but that does trick students the first time they see it. Angle of depression. So when I drew my triangle, this was the first triangle that I had. The angle of depression is from a horizontal line. I didn't have this line in originally, so I put a horizontal line in, and the angle of depression is from that going down. So that diagram, that's everything that's been given. Is there anything else that I can do to try to solve this problem? Right now, if I'm looking at this triangle, I don't have any interior angles, right? I don't know this acute angle, nor do I know this bottom one. And I need to know one of them. I need a reference angle. You could use either of these options. So I'm going to show you both of these options. Option 1, if you use the Z pattern, the Z pattern says that this line, this transversal line, and the ground make the letter Z. The interior angles of that Z are the same. So this angle down here would also be 63 degrees. That is one option. Another option would be to look at these two angles up here and say those two angles have to make 90 degrees. So if one is 63, 90 minus 63 will give you 27 degrees up there. It doesn't matter which one you choose. Depending on the reference angle, you might label your sides differently, but that's okay. You should get the same final answer. Because I've got that top angle, that's the angle I'm going to use. Now that you have your diagram, it's the exact same as before. So if you want to pause the video and work through the solution, you can. I'm going to continue working through it, so I do encourage you pause, calculate an answer. Okay, so if I want to solve the angle, first thing I need to do is label my sides. From 27, 13 is the opposite. X is the adjacent side. You're thinking about SOH CAH TOA. Opposite and adjacent says to use tan. So I'm going to set up my equation saying tan of the angle, 27 degrees, equals opposite over the adjacent side, which is the height of the monument. It's the unknown. Okay, multiply by x, and then divide by tan 27 degrees. Make sure your calculator is in degrees, so I just had to change mine. So 13 divided by the tan 27 degrees, x is approximately 25.5. Remember, I do want to see your initial substitution, how you isolated x, and then the answer you got from your calculator. But since this is a word problem, you also need a word answer. So therefore, the monument is 25.5 meters tall. Next question. Again, I would take a minute, pause the video, read the question, try to draw the diagram. So hopefully you had a diagram like this. Altitude is the perpendicular measurement of height. So that 2,000 meters would be perpendicular to the ground. How I drew this, my triangle is on the kind of the bottom side. The angle of depression, again, I didn't have this line, but to add in an angle of depression, I need a horizontal line. So I got the 23 there. What I am trying to find here, so I didn't mark X on it because there is some ambiguity around this. How far away is the fire? You might think of it like this. If the helicopter was going to fly diagonally and get just over top of the fire to drop water, you might want to solve that. Or if you're thinking it's going to fly over top and drop it from that height, you would find this X. I will be clear on the test. Okay. For this one, I'm just going to put it here so I don't use tan again. Okay, the last question had tan in it. So there's my triangle. I still need an interior angle. I'm going to use the concept of the Z pattern. If that angle of depression is 23, The Z pattern says that angle inside is also 23. Now I label my sides. 2,000 meters is opposite, X is hypotenuse, SOH CAH TOA, O and H says use sine. So I'm going to say sine of the angle 23 degrees equals opposite over hypotenuse. You've done a lot of this stuff, so your next line might just be swapping out these two, switching places, and that's okay with me. And then 2,000 divided by sine 23, you get 5,118.6 approximately. So make sure you round. And a word problem, or a word answer, sorry. The fire is approximately 5,119 meters away. Right. Again, this question is not really clear if it's talking about this side or that base. On a test, I will be very clear. Third problem. Again, pause the video, try to draw the diagram. Once you have a diagram, resume the video. Okay. Do you have a diagram something like this, where you've got a right triangle, the leg going up is 10 meters, the leg going across is 100. What it wants us to find is the angle of inclination. That's another way of saying angle of elevation. So we're trying to find that angle because it's from the horizontal line going up. I'm going to label my sides, opposite, adjacent, SOH CAH TOA, opposite and adjacent says to use tan. So tan theta is the opposite over the adjacent. If you want to reduce that fraction to 1 over 10, you absolutely can. Now you'll get the same answer either way. I want to get theta by itself. So remember, this is what we looked at last week. To get theta by itself, we want to get rid of tan. And to get rid of anything in an algebraic equation, you do the inverse. So on your calculator, you have those tan -1, sine -1, cos -1. You have the inverse trig functions. So you have to hit shift and tan to get there. 10 divided by 100. It wants it to the nearest tenth of a degree. The nearest tenth is 1 decimal. So it's about 5.7. So it has a 10% gradient, but the angle of inclination is about 5.7 degrees.
They come out and they introduce themselves. And they...
Last question there. If you want, you can pause the video and then draw a diagram and resume it once you have a diagram. So there is a diagram. It doesn't need to have an actual building or a car, but I'm going to kind of zoom out to simplify this diagram. So I'm assuming you would just like, here's your building. Buildings are always perpendicular to the ground, and then here's your car. The building is 52 meters. Angle of depression from a horizontal line going down is 36 degrees. Oops, I missed the second part. If you are 1.65 meters tall, so I got to erase this. So there's the building. You have to add another 1.65 meters because that's where you're looking from up there to your car. There's the horizontal line, angle of depression 36. So really, when you're looking at that, the height that you're looking down from is the 52 meter building, plus your 1.65 meters. So this whole height is 53.65. How far is the car from the building? So that would be looking for this side down here. But once more, a little bit cleaner. X 53.65. That exterior angle is 36. I'm going to, you can use this angle by taking 90 minus 36, or the Z pattern and say this angle down there is 36. Does not matter. I'm going to find that top angle just to do something different than the last example. And you get that inside angle to be 54 degrees. From this angle, X is the opposite. 53.65 is the adjacent. SOH CAH TOA, opposite and adjacent, says to use tan. Bring that 53.65 up and multiply it. And then now you go to your calculator to get the answer. It doesn't say how many decimals to use, so you can round it however you want as long as you round it correctly. I will say 73.8. Therefore, the car is 73.8 meters from the building. Okay. So those are word problems, and the tricky part is going from the words to the diagram. Once you have the diagrams, then it's the same math that we did last week. Then it's just kind of knowledge stuff. Okay. The homework for today is that right there. Question 17, my hint is you're going to have to use substitution. You're going to get two tan equations. Each of those two equations will have two unknowns. So you've got that system, kind of like Unit 1. The solutions to that one, if you are unsure, are on the website. So if you go to the website and go to Chapter 5, you can see those textbook solutions. Okay? Good luck.